We've now added tuples, generalization of strings, an ordered sequence of elements, where the elements can be any structure. And we've already seen that a lot of the operations we wanted on strings we're going to have on tuples. We're going to add another kind of structure called a list, and it looks a lot like tuples. Again, lists are ordered sequences of values. Each one's identified by an index, so it's going to support all the same kinds of operations I saw before. The difference here is that we're going to use these square brackets rather than the parentheses to distinguish a list, or to create a list, as opposed to a tuple. So they got a little difference in terms of how they're going to look. And as a consequence, one nice thing is that singletons are now pretty straightforward. It's just a square bracket, the entry, and another square bracket. I don't have to put that annoying comma in that I had to do with tuples in order to distinguish between an arithmetic expression and a tuple with just one element. Looks much the same, so what's the big deal? Well, there's one very big difference, and it's a really important one, which is that lists are mutable. And what does that mean? It means we can change them. What does that mean? Well, things like ints, floats, strings, and tuples are immutable. And that means that we can't go in and change an element inside of them. Now, for ints and floats, that's obvious. In tuples, we just introduced, so we sort of have to accept that on faith. But if you think about strings, you can get elements of strings out, you can slice into strings, but you can't go in and directly change one character in a string. They're not mutable. They're immutable. They don't change. On the other hand, lists can be modified after they're created. And why would we want to do that? Well, in part, because there are going to be some problems where that's really valuable. So what does that mean? Some data objects we really want to treat as if fixed. It says we create new versions of them, we can bind variables to them, but we don't want to change them. And this is usually valuable when those data objects are going to be frequently referenced, but where the pieces inside of them don't change. Why would we want to support having ability to change them? Because that can just lead to bugs. On the other hand, there's going to be some instances where the data objects may want to support modifications to elements inside of them. Why might that happen? Imagine you've got a really large database of personnel information. You want to do things like change salaries. You don't want to have to make an entirely new copy of the database just to add in a new salary. You'd like to be able to go inside and change a piece of that. So, lists are going to support that kind of operation by enabling us to go in and mutate or alter elements of the pieces. One issue to keep in mind is that while mutable structures give us more flexibility, they also are more prone to programming errors. If I've got two different pieces of code, both pointing to the same list, and I have one piece of code change or mutate a portion of the list, I want to make sure that that other piece of code is aware of that. If not, I can get myself into some really interesting bugs. So, there's a cost, but there's a bonus. All right, let's look at an example of what this means. So let's create a couple of lists. And in fact, over here in my idle shell, I'm going to do that. Let me just create a couple of lists. And I'm going to call Tex as a name for a couple of great technical schools. And notice the angle braces to get them for me. And I'm going to create Ivies. I'm not going to do all of them, but I will again create a list of some great schools. We'll do Harvard, we'll do Yale, and we'll do Brown. Okay, and if I print them out, I can say what is the value of Tex, and it just gives me that list. On my slide, I've given you a visualization of that. So think of this as Tex and Ivies sitting up in that global environment. After all, I just typed them into the shell for Python. And what do? Well, they point to a structure in memory somewhere that has that sequence of elements inside of it. As I've said, I can treat this as if they were just ordered sequences. So I could say something like, what is the first element of the Ivies? Remember, we start indexing at 0, so that gives me back Yale, which is nice. And I could slice if I wanted to. I could say, give me back the Ivies, everything up to the second one, and that gives me the 0th and first element. So I can do things I'd expect to do on that. Let's see what happens when we start putting things together. So I've got two lists, a list of tech schools, I've got a list of Ivies. Let's now create what looks like two different lists of universities. So the first one I'm going to call Univs for universities, and it's going to be a list of the techs and the Ivies. And I'm going to create what looks like the same thing. I'm going to call it Univs1, and I'm simply going to recreate that sequence. Caltech, that was the first one, and since I'm creating a list of these lists, I'm going to put a comma in there, and then I'm going to do Harvard, Yale, and Brown. Are these the same thing? Well, let's print them out. if I look at univs, yeah, nice. It's a list of 2 elements, the first of which is a list of 2 elements, the second of which is a list of 3 elements. And if I look at univs 1, looks exactly the same. They certainly print the same. So it is easy to think that these might in fact be the same thing. But they're not. And let me show how I can test that. Let's evaluate the following little command up here. An append is a method associated with lists. We'll come back to methods later on. That dot notation basically says, if I type in text, it's a list. The dot says get the method append associated with it. Don't worry what a method is, but basically think of it as a function that is going to take an argument, in this case, a single element, RPI, and it is going to attach that element to the end of the list text. So, what does it do? It's an important thing here. It doesn't create a new list. It mutates the existing one. It takes text as a list and changes it. It mutates it to add a new element to the end, extending the list by 1. Now, as a consequence, if we print out univs, notice we now have in that first element, MIT, Caltech, and RPI. We have changed what's inside of there. We have mutated text, not univs. In fact, let's just check it. Let's go look at text, and there's text. But again, if I go back to univs, there it is. And now, what happened to univs 1? Aha! It didn't change. And that's an important point. Look at the form of univs 1. It has just the first 2 pieces to it. And in fact, if I go to the next slide, we've captured that. If I print out univs, I get out MIT, Caltech, RPI, followed by Harvard, Yale, Brown. But for univs 1, I just get MIT, Caltech, and then Harvard, Yale, Brown. Why? Well, this is where the mutability comes in. So let's think carefully about what we had. Before I did that append, I'd had a binding for text, and I had a binding for ivies. We created those. They said were lists. And then what did I do? I said, let univs equal, and in fact, let me just write it out here. I bound univs to text and ivies. And what does that say? It says make a list. Okay, so there's univs. It's going to make a list, and it says the value of the first element is going to be the value of text. So, aha, it's just a pointer to that list. And the value of the second argument, or the second element, is just the value of ivies. So, aha, it's just pointing to there. So, univs is a list whose elements are just pointers to other lists. On the other hand, what did I do when I created univs 1? Well, if you look back, you'll see that, in fact, I created it by actually typing out lists. I said univs 1, just to say a little bit of it, I said univs 1 was going to be, and then I said, quote MIT, quote Caltech, comma, and then I did a bunch of other things. I'm not going to do all of it. But this is telling Python, create a list with those strings inside of it. So, in fact, that's exactly what it did. Univs 1 is going to create a list, but it creates it with a new version right there. Notice text is not pointing to this. There's a new version right there. Ivies is not pointing to this because I created them and inserted them inside of this larger list. That's important because now when I did that append on text, what did it do? It went over here and changed that. It added that into the end of it. That means that univs changes because it sees that. But what about univs 1? This is a completely different list. Nothing changed there. Let's make some observations out of this. The elements of univs are not copies of the list to which ivies and text are bound, but are the lists themselves. I got the value of text, which pointed to the list. And this effect is something we call aliasing. Basically, what does aliasing says? It says we have 2 distinct paths to a data object. One is through the variable text in this case. There's a second one through the first element of the list object to which univs is bound. And one of the effects of that is that I can mutate an object through either path, but the effect will be visible to both. And I just saw that back here, right? When I mutated text, but univs changed. That sharing of data is really important, and that mutation, that ability to change things is really important. This is very convenient, but it also can be really dangerous. It can be treacherous, because if I had something that was changing text, and I didn't realize that univs inherited the text structure, I've now changed something inside of univs. And if you think back to the code I just typed in there, you saw nothing that said make a change to univs, but changing a part of it had that effect. So aliasing is a valuable tool, but it is going to occasionally lead to some problems, and we have to be just careful about it. Now, what else can we do? Well, we can certainly change elements directly. So if I go back, for example, and I look at text, there's my list of tech schools, MIT, Caltech, RPI. I might decide I want to change the list. So I can literally say, change the second element of text, and I do it just with an assignment statement. I'm going to pick up WPI. And now, if I look at text, aha, that element has changed. I've mutated it. By the way, if I go back and look at UNIVs, it has also changed. I've now got WPI in the first portion of that element. Just to remind you, it says I can mutate elements of lists. I cannot do the same things with tuples. So if I do an example where I create a tuple, I can look at temp. But if I now say, and I can certainly get out, for example, first element of temp, but if I attempt to change that, as I just did above here, by putting in something new, it's going to complain. And it says you can't do it because these things are not things that can be mutated. So now we've got lists. Let's see what we can do with them. As I just said, stressing it, I can't do that with tuples.